Chapter 2. Inside our Earth. Earth is dynamic. It is always on the move, rotating and revolving, and constantly changing internally and externally. To know how changes take place on the Earth's surface, we need to study the structure of the Earth. A detailed study of the interior of the Earth has been done by scientists and geologists. Nothing in this universe is static. It changes from time to time. The Earth was formed about 4,500 million years ago. Since its birth, the Earth is undergoing many changes. Interior of the Earth, experiments and observations of scientists tell us about the interior of the Earth. The most important source is seismic waves or the earthquake waves generated by earthquakes. Tremors and vibrations in the crust of the Earth are called earthquakes. Originating at the focus of the earthquake, they travel towards the Earth's surface in different directions at different speeds. Their speed depends on the nature of material they pass through. Seismic waves are of two main types: P waves, primary waves, and S waves, secondary waves. The study of these waves enables us to know about the Earth's interior. The Earth is made up of three layers: crust, mantle, core. 1. Crust. It is a thin, solid layer covering the outside, or it is the uppermost layer of the Earth. Its thickness differs from place to place. The crustal part that makes the sea floor is 4 to 7 kilometers thick. In the continents, it is in an average 35 kilometers thick. The crust is even 70 kilometers thick beneath some mountains. The continental crust is composed of rocks which is rich in silica and alumina, thus this layer is known as sill. On the other hand, the oceanic crust is made up of rocks rich in silica and magnesium, thus, this layer is known as seama. Rocks and soils form the uppermost layer of the crust. 2. Mantle. Beneath the crust is a very thick layer called the mantle. This layer is also called asthenosphere. It extends up to 2,900 kilometers in depth. The entire mantle is not homogeneous. Its upper part up to 100 kilometers is the upper mantle. Beyond 100 kilometers lies the lower mantle. 3. Core. The innermost part of the Earth is known as the core. It has a radius of 3,470 kilometers divided into two parts, outer core and inner core. Iron and nickel are the important constituent elements of this layer, due to which it is called knife or the core of the Earth. When people dig the crust for minerals or drill for oils, they find rocks hotter inside than they are near the surface. Rocks and minerals. Earth is a planet with rocks and minerals filled all over it. The rocks forming the crust of the Earth are in solid state. Any mass of harder portion of the Earth's crust can be called a rock. A rock can be defined as an aggregate of minerals. Rocks make up most of the solid materials of the lithosphere. Rocks may be hard or soft. Most of the rocks are mixtures of various minerals in different proportions. A mineral is a natural substance having a definite chemical composition and physical properties. A rock having a large proportion of a single mineral, so that the mineral concerned can be extracted from it economically, is called an ore of that mineral. Magnetite is an ore of iron. A mineral is a natural substance having a definite chemical composition and physical properties. A rock having a large proportion of a single mineral, so that the mineral concerned can be extracted from it economically, is called an ore of that mineral. Magnetite is an ore of iron. Rocks, types of rocks. Earth's crust is formed by a variety of rocks differing from each other in composition, texture, color, etc. On the basis of the mode of their formation, the rocks can be categorized into three groups: 1. Igneous rocks, 2. Sedimentary rocks, 3. Metamorphic rocks. Each of these broad groups can be further subdivided on the basis of their physical and chemical properties. 1. Igneous rocks. Igneous rock or magmatic rock is one of the three main rock types, the other being sedimentary and metamorphic. Igneous rock is formed through the cooling and solidification of magma or lava. In the interior of the earth, the rocks are in a molten state. This molten material is called magma. It is ejected from the interior of the earth to the surface through volcanic activity in solid or liquid state. Igneous rocks are formed through deposition and solidification of volcanic material. Igneous rocks are of thermal origin. Igneous rocks are known as primary rocks since they were the IRST rocks to be formed. They are generally hard, have no layers, and do not contain fossils. Besides being crystalline, most of them are impervious, i.e., water cannot percolate through them. Uses: as igneous rocks are generally compact and do not get eroded rapidly, they make good building materials. Granite, basalt, gabbro, dolerite, feldspar, pumice, obsidian, and scoria are some examples of these rocks. Ores of most of the metallic minerals are associated with igneous rocks. 2. Sedimentary rocks. Many elements like rain, wind, ice, plants, and animals break rocks into small particles. These rock particles are carried away by running water, wind, and ice, and are deposited in an area that is sunk below its surroundings or in hollow areas. The deposited materials are called sediments. The loose sediments are then compressed and hardened to form layers of rocks. There are sedimentary rocks. The sediments are derived by denudation of the rocks by agents of erosion like rivers, glaciers, winds, and waves. Agents of erosion carry the eroded particles of rocks to the water bodies and deposit them there. Such deposited material is called sediment. Sediment contains loose particles of gravel, sand, silt, and clay in various proportions. Over a period of time, a significant thickness of sediments accumulates and gets consolidated or compacted to form hard rocks. The consolidation of sediments takes place due to the pressure of overlying materials and the presence of cementing substance like lime. They are called sedimentary rocks as they are formed through the process of sedimentation. They are also called secondary or derived rocks as they are derived from other rocks. Fossils. A fossil, Latin fossilis, used for, obtained by digging, is any preserved remains, impression, or trace of any once living thing from a past geological age. The sedimentary rocks contain layers of the sediment which are generally soft. Most of them are porous and permeable. The remains of plants and animals may get preserved in the layers of sediments. These remains are called fossils. Most of the fossils are found in sedimentary rocks. Fossils help in determining the age of the sedimentary rocks. 3. Metamorphic rocks. Under very high temperature and pressure, igneous and sedimentary rocks change their form. Such changed rocks are called metamorphic rocks. These are very hard rocks. The process of metamorphism takes thousands of years. The term metamorphism means alteration or transformation. It may involve both physical as well as chemical changes in the pre-existing rocks. It takes place when rocks are subjected to high temperature or pressure. The original minerals found in a rock are altered and new minerals are formed due to extreme pressure generating heat or by coming in contact with volcanic material. The joints in the rocks are pressed and crystallization may occur. The rocks thus formed are more compact, harder, and bulky than the original rocks. Metamorphic rocks may have layers which are highly compressed. Fossils are not found in these rocks. Most of the metamorphic rocks are impermeable. The process of metamorphism may take a very long time. Various sedimentary and igneous rocks are metamorphosed to produce new rocks. Sandstone, for example, may be changed into quartzite, limestone into marble, clay and shale into slate, granite into gneiss, basalt into schist, and coal into graphite. Rock cycle. Rocks on Earth can change from one type to another in a repeated pattern. This process is called the rock cycle. You've learned that when hot magma cools, it turns into solid igneous rock. Over time, these rocks break into smaller pieces, which are then carried away and deposited, eventually forming sedimentary rocks. When igneous or sedimentary rocks are subjected to heat and pressure, they transform into metamorphic rocks. Under intense heat and pressure, these metamorphic rocks can melt back into magma. This magma can then cool and harden once more, becoming igneous rocks again. Minerals. Minerals are naturally occurring inorganic substances made up of one or more elements. They have definite physical and chemical properties. Most minerals have a crystalline structure. The size of crystals varies depending on the conditions under which the rocks form. Quartz is one of the most common minerals found on the surface of Earth. A mineral possesses a definite chemical composition. Most of them are naturally occurring inorganic substances. They may be made up of atoms of a single element or of more than one element combined together in a definite proportion. Minerals made of a single element include sulfur, gold, diamond, and graphite. Diamond is used in jewelries and graphite is used in pencil leads. The minerals made of more than one element include quartz, CO2, hematite, FeO2, galena, PbS, and calcite, CaCO3. The main constituent of sand is found on the banks of rivers or on sea beaches. Its chemical composition is fixed. There are more than 2,000 minerals present in the Earth's crust. Formation of minerals. The formation of different minerals from the same elements shows the different conditions prevailing at different regions inside the Earth where they are formed. For example, the carbon atoms present in the upper part of the Earth join to form a soft mineral called graphite, having loosely held layers of carbon atoms. Where graphite mineral is formed inside the Earth, the pressure and temperature there are not very high. The same carbon atoms present deep inside the Earth join to form the hardest natural substance called diamond, having strongly held carbon atoms. It shows the presence of great pressure and high temperature deep inside the Earth. Silicates. Two of the most abundant elements found in the Earth's crust are silicon and oxygen. The compounds containing a metal, silicon and oxygen joined together are called silicates. Silicates. Two of the most abundant elements found in the Earth's crust are silicon and oxygen. The compounds containing a metal, silicon and oxygen joined together are called silicates. Silicates are the most common rock-forming minerals. For example, the rocks like granite, sandstone and shale are all made up of silicate minerals. In fact, granite, sandstone and shale are called silicate rocks.